So a difference of two squares is a special approach that we use in order to factorize expressions that have got one squared term, take away another squared term or a square number. So as we can see, in the brackets here, we've got x in both the brackets, and in one of the brackets, we've got x plus 2. In the second bracket, we've got x minus 2. So if we were to expand this bracket, we would have x squared minus 2x plus 2x minus 4. And if we simplify these two terms, that would just give us 0, and we would be left with x squared minus 4. Now, as we can see, x squared is a squared term, and 4 is also a square number. So when we have expanded these brackets, we have got x squared minus 4. X squared minus 4 is an example of an expression in which we can use a difference of two squares to factorize it. So if we want to factorize any difference of two squares, we first find the square root of the first term, which is x squared. The square root of x squared is x, so we are just going to put x as the first term in both brackets. The square root of 4 is 2, so in the first bracket we will put plus 2, and in the second bracket we will put minus 2. It does not matter whether we put minus 2 first or plus 2, so we could also write this as x minus 2 first and then x plus 2. And this is how we use a difference of two squares to factorize expressions. So for number 1, 2 and 3, we have been asked to factorize each expression completely. So for number 1, we have x squared minus 49, and 49 is a square number. So for the first term of each bracket, we put x. Square root of 49 is 7, so for the first bracket, we're going to put plus 7, and for the second bracket, we are going to put minus 7, and that is our factorized form. For number 2, we have y squared minus 100. 100 is a square number, so for the first term of each bracket, we are going to put y. The square root of 100 is 10, so for the first bracket, we could put plus 10, and for the second bracket, we could put minus 10. For number 3, we've got 49 minus a squared. 49 is a square number, and a squared is our second term, so we're going to put a this time as the second term of each bracket. The square root of 49 is 7, so we're going to put 7 plus a for the first bracket, and for the second bracket, we are going to put 7 minus a. For number 4, 5 and 6, we have been asked to solve the equations. So for number 4, we've got x squared minus 4. So we could put x as the first term of each bracket, and the square root of 4 is 2. So we could put x plus 2 and x minus 2 is equal to 0. In order to solve it, we would have to separately equate both of these brackets to 0. So x plus 2 is equal to 0 and x minus 2 is equal to 0. So for the first bracket, if x plus 2 is equal to 0, that means x here has to be minus 2. And for the second bracket, if x minus 2 is equal to 0, that means x has to be 2. And these are our two solutions. For number 5, we have c squared minus 81 is equal to 0. So we will put c as the first term of each bracket. And for the first bracket, we will put plus 9. And for the second bracket, we will put minus 9. So in order to solve these, we have to separately equate both brackets to 0. So for the first bracket, if c plus 9 is equal to 0, that means c has to be minus 9. And for the second bracket, if c minus 9 is equal to 0, that means c has to be equal to 9. For number 6, we've got 25 minus m squared is equal to 0. So we are first going to put m as the second term of each bracket. And the first term is 25. Square root of 25 is 5. So we are going to put 5 plus m for the first bracket and 5 minus m for the second bracket. In order to solve this, we have to equate both brackets to 0. So if 5 plus m is equal to 0, that means m would have to be minus 5. And for the second bracket, if 5 minus m is equal to 0, that means m has to be 5. And these are our two solutions for number 6. So before we can apply the difference of two squares rule, the first thing we always check is whether there's a common factor in all the terms. we first have to factorize it out. Let's look at some examples here. So for number 1, we have 2x squared minus 50. So the first step is to find the highest common factor, and we can see that both 2 and 50 are divisible by 2. So we are first going to factorize the 2 outside. In order to make 2 into 2x squared, we have to multiply that by x squared. So we open the bracket and put x squared. And in order to make 2 into 50, we have to multiply that by 25. So now we can see inside the bracket, we have a difference of 2 squares. So we are going to keep the 2 outside the bracket, and the square root of 25 is 5. So we will put the first bracket as x plus 5, and the second bracket is x minus 5. So for number 2, we've got 4y squared minus 36. And the highest common factor in both terms is 4. So we are going to put the 4 and then open our bracket. In order to make 4 into 4y squared, we have to multiply that by y squared. And to make 4 into minus 36, we multiply that by minus 9. So inside the brackets, we've now got a difference of 2 squares. So we keep the 4 outside. The square root of 9 is 3. So for the first bracket, we are going to put y plus 3. And for the second bracket, we could put y minus 3. For number 3, we've got 50 minus 18a squared. The highest common factor of 50 and 18 is 2. So we are going to put 2 outside of the bracket. And in order to make 2 into 50, we have to multiply that by 25. In order to make 2 into minus 18 squared, we would have to multiply that by minus 9a squared. Now inside the bracket, we notice that we've got a difference of 2 squares. So we could keep the 2 outside the bracket as it is. The square root of 25 is 5, so we are going to put 5. And the square root of 9a squared is 3a, so we are going to put 5 plus 3a for the first bracket and 5 minus 3a for the second bracket. For number 4, we've got 6c squared minus 24. So the highest common factor of 6 and 24 is 6, so we will keep 6 outside the bracket. And in order to make 6 into 6c squared, we have to multiply that by c squared. In order to make 6 into minus 24, we have to multiply that by minus 4. We've now got a difference of 2 squares in our bracket, so we keep the 6 as it is, and the square root of 4 is 2. So for the first bracket, we can put c plus 2, and the second bracket would be c minus 2. For number 5, we've got 8m squared minus 72. So the highest common factor of 8 and 72 is 8, and we open the bracket, and to make 8 into 8m squared, we would have to multiply that by m squared. In order to make 8 into minus 72, we would have to multiply that by minus 9. So we've now got a difference of 2 squares in the bracket, so we keep 8 as it is, and the square root of 9 is 3. So for the first bracket, we will put m plus 3, and for the second bracket, we will put m minus 3. For number 6, we've got 126 minus 14m squared. The highest common factor of 126 and 14 is 14, so we will put 14 outside the bracket. In order to make 14 into 126, we would have to multiply that by 9. And in order to make 14 into minus 14m squared, we would just have to multiply it by minus m squared. So we will keep the 14 outside the bracket. The square root of 9 is 3, so for the first bracket, we would put 3 plus m, and for the second bracket, we would put 3 minus m. Sometimes we may have to factorize variables with higher powers. So we first need to check whether if it's a difference of 2 squares in disguise. So if we look at the first one, we've got x to the power 4 and minus 16. 16 is a square number, and we know that in order to get x to the power 4, we would have to multiply x squared by itself. So we can first factorize this as x squared minus 4 and x squared plus 4. We can then see that here we've got a square, and 4 is also a square number. And because we are doing x squared take away 4, this first bracket is a difference of 2 squares. So we can further factorize this as x minus 2 and x plus 2. We can then keep the second bracket as it is, x squared plus 4. And there we have our 3 factors for x squared minus 16. For number 2, we've got y to the power 4 minus 81. So in order to get y to the power 4, we would have to have multiplied y squared. So the first term in the bracket will be y squared. 81 is a square number, and the square root of 81 is 9. So we're going to put y squared minus 9 and y squared plus 9. As we can see, the first bracket is the difference of two squares. So we can further factorize that as y minus 3 and y plus 3. And the second bracket, which was y squared plus 9, would remain as it is. And that would be our final answer for number 2. So for number 3, we've got p to the power 4 minus 1. In order to get p to the power 4, we would have had to multiply p squared by itself. So we can write the first term of each bracket as p squared, and the square root of 1 is just 1. So we could put p squared minus 1 and p squared plus 1. We can then notice that the first bracket is a difference of two squares, which we can further factorize as p minus 1 and p plus 1. So that is the first bracket factorized further, and the second bracket would just remain the same, and we would put it as a third bracket for our final answer, p squared plus 1. For number 4, we've got 16x to the power 4 minus 49. So we've got 16, which is a square number. X to the power 4 means that we have multiplied x squared by itself, and 49 is also a square number. So the square root of 16 is 4, so we could put 4. And to get x to the power 4, we are multiplying x squared. The square root of 49 is 7, so for the first bracket we're going to put 4x minus 7, and for the second bracket we're going to put 4x plus 7. Because in the first bracket we've got 4, which is a square number, but 7 is not a square number, so we cannot factorize that any further. We will leave this as our final answer. For number 5, we've got c squared, so we could put c as the first term of the bracket, and in order to get x to the power 4, we would have had to multiply it by x squared, so we could put c minus x squared as the first bracket, and the second bracket would be c plus x squared, and that would be our final answer. For number 6, we've got y to the power 4 minus 36. The square root of 36 is 6, and to get y to the power 4, we would have to multiply y squared by itself. So we could put y squared minus 6 as the first bracket, and the second bracket would be y squared plus 6. And that is our final answer for number 6. So here are a few practice questions. You can pause the video and have a go, and then come back to have a look if you got the same answers. So for number 1, we have to factorize 36x squared minus 49. So 36 is a square number, x squared is a square number, and 49 is also a square number. So if we look at the square root of 36, that's 6. The square root of x squared is x, and the square root of 49 is 7. So we are going to put the first bracket as 6x minus 7, and the second bracket is 6x plus 7. For number 2, we've got a to the power 4 minus 25. In order to get a to the power 4, we would have had to multiply a squared by itself, so we are going to put a squared as the first term. The square root of 25 is 5, so we are going to put the first bracket as a squared plus 5, and the second bracket as a squared minus 5. For number 3, we've got 1 minus y squared, and both 1 and y squared are square numbers. So we would write this as 1 minus y and 1 plus y. For number 4, we have to factorize 12a squared minus 48, and we now need to check if this could be a difference of two squares in disguise. So we need to look at the common factors of 12 and 48 that we could factorize. So we've got 2, we've got 3, and we've got 4. So let's begin with 2. So if we factorize 2 outside, in order to make 2 into 12a squared, we would have to multiply it by 6a squared. And in order to make 2 into 48, we would have to multiply it by 24. Neither 6 nor 24 is a square number, so we know that could not be a difference of two squares. If we factorize 3 outside, in order to make 3 into a squared, we would have to multiply it by 4a squared. And to make 3 into 48, we would multiply it by 16. Here we can see both 4 and 16 are square numbers, so that is definitely a difference of two squares. And if we factorize 4 outside, we would have 3a squared minus 12. And as we can notice, 3 and 12 are also not square numbers. So we are going to factorize 3 outside because that gives us a difference of 2 squares in the bracket. So if we rewrite this now as 3 bracket 4a squared minus 16, we can factorize the bracket as a difference of 2 squares. So we would put the 3 outside as it is. The square root of 4 is 2, so we would put 2a, and the square root of 16 is 4, so we would put 4. So the first bracket would be 2a minus 4, and the second bracket would be 2a plus 4.